All right, welcome back. Calculus 1, still in 2.3. There's a little batch of homework questions that make you do this limit. Now, this is a very famous limit, and I hate to spill the beans right away. We're just practicing doing this limit here in Chapter 2. As soon as we get to Chapter 3, we're going to learn how important this is. I could go ahead and tell you, this is the derivative. This is the slope of the tangent line, but I don't really want to get all into it right now. I'll get into it later. Let me say this. Without that limit, you've probably done something like this before, maybe in pre-calculus, maybe in college algebra, maybe it's because they were trying to prepare you for calculus. They knew you'd have to do this thing. They call it a difference quotient. It's a quotient, and it's the difference. It's called a difference quotient. I like to teach my students that, isn't that a y value? F of x is a y value. And then this is a different x. This is x plus delta x. That's a change in x. So we're at a different x. So this is a different y value. And I have a y value minus a y value. If I have a y value minus a y value, isn't that a change in y over a change in x? So isn't this a slope? Yes, it is. And then I'm doing this limit as delta x approaches 0, so it's kind of like a slope at, the slope between 2 points, but we're letting delta x go to 0, so we're letting those 2 points kind of come in as 1 point, which is why I mentioned the slope of the tangent line. So maybe you can think about all those ideas. Those ideas aren't necessary yet. They're just trying to get you to crank out this limit and understand how to do it. Some students do not understand how to plug this stuff in. I'll help you. So first off, you're doing this limit, and you can do it to various different functions. I might do a couple examples, but I want to do this limit, and I want to do it to this function. But I could make up another function. We could do it, maybe we'll do it to this function next. You can do it to that function. You can do it to any kind of function. But it takes a little work, so let's see what I'm trying to do. I'm trying to do this limit. So here I go. I'm going to write down the limit as delta x goes to 0. By the way, treat delta x as a separate variable than x. In fact, a lot of students like to use the letter h. Maybe you remember that. Maybe somebody taught you to do that. I'm going to use delta x, but it's not an x. It's a separate variable. So it's a different letter. It's a different quantity. Okay, what am I doing? The limit is delta x goes to 0. I want to do f of x plus delta x. And what that says is go to your function and plug in x plus delta x. And that means you plug x plus delta x in for that x, and you square it. You plug x plus delta x in for that x, and you multiply by 5, and you have a minus 7. So that was me plugging x plus delta x into the function. So I've written the first part of that, minus f of x, which is just subtracting the function itself. So when you subtract something, please put it in parentheses. I'm subtracting the function itself. So I've got the function with an x plus delta x in it, and I've got the function with just an x in it, and I'm subtracting them. That's this long numerator, all over delta x. Now the truth is, if you tried to do this limit right now and let this delta x go to 0, that would be a 0, and your numerator would be a 0. You'd have one of these 0 over 0 situations. So don't do it. Don't even bother. What you got to do is clean this all up, and a lot of stuff cancels. Eventually, this delta x is going to cancel, and then you can do the limit. So it takes algebra, of course. I'm going to FOIL this out, of course. I'm going to FOIL this binomial when you get x squared plus 2x delta x plus delta x squared. That's what happens when you FOIL a binomial. You get that middle term. Now, wait a minute. I should multiply by negative 2. If you don't mind. Let's see. I think I'll do that right here. I'm going to multiply by negative 2x squared, negative 4x delta x, and a negative 2 delta x squared. So I FOILed this out, and then I multiplied by the negative 2, and there it is. What's left? A positive 5x plus 5 delta x. That 5 distributes. A minus 7 What about down here? Distribute the negative sign. It's a positive 2x squared, a negative 5x, and a positive 7. All over delta x. And we're still trying to take the limit as delta x goes to 0. I should have told you to turn your paper sideways. Look at that. But a lot of stuff cancels. Can you see it? The negative 2x squared will cancel with that positive 2x squared. That positive 5x cancels with that negative 5x. That negative 7 cancels with that positive 7. That's usually how it works. In fact, usually what happens, everybody cancels that doesn't have a delta x. So everybody that's left has a delta x in there. There's this term, and there's this term. I guess I always run out of room. Look, I'm going to move right up here to this corner here. I'm going to move up here to this corner. I've got the limit as delta x goes to 0. And what I'm left with is these three things in the numerator. And you know what? They all have a delta x in them. I'm going to factor that delta x out. So when I factor a delta x out of that, I'm left with negative 4x. When I factor a delta x out of that, I'm left with negative 2 delta x. And when I factor a delta x out of there, I'm left with a positive 5. And it's all over delta x. If you try to do the limit right now, you got a 0 over 0. It's not very obvious. Don't do it yet. In fact, the whole purpose of us pulling out that delta x was so we could cancel it. So I'm canceling that delta x. And now that leaves me with this limit. As delta x approaches 0, I'm left with this. The negative 4x, the negative 2 delta x plus 5. So now do the limit. And what that means is this delta x will go to 0 when it's multiplied by that 2. That goes to 0. This term goes to 0 because we did the limit. We let delta x go to 0. And what am I left with? The answer is negative 4x plus 5. So that's a very famous limit problem. We'll do that again up in chapter 3, but they definitely hit us with it in 2.3. Let's try one more. I'm going to erase this one. So you got to hit pause maybe if you want to get some of these things down. I'm going to just try another one. I want to try something different. That was fun. You foil that out. Sometimes students have a hard time with that. I think you got to practice it. This is a difficult one. With the square root of x, it's going to be a little more difficult. I'm going to erase this. I'm going to erase this. Get rid of this. So when you do this to a function, you kind of get this new function, okay? And like I said, it's the slope of the tangent line. But anyway, when you do this to that, so when we did this to the last function, we got this answer. When I do it to this function, I don't know. We'll see what we get. We'll get some new function. It's called the derivative, actually, but no big deal. We're just trying to do this again. So this is a very famous limit. We can do it to various functions. Now I want to do it to this function. So here I go. The limit as delta x goes to 0. And what I do is students, again, they get a little confused. Who's plugging into who? You're reading this, and what this says is it says plug x plus delta x into your function. Okay, plug x plus delta x into my function. Okay, I did what they told me to do. Minus the function itself. Okay, minus the function itself, all over delta x. So that's how you set up this limit every time. Plug x plus delta x into the function, minus the function itself, all over delta x. And we can do it to various different functions. Now we're presented with this challenge. There's nothing to FOIL out here. This is different. I'm not FOILing this one out. I do have these nasty square roots here, and we did a problem before where the algebraic way to clean up these nasty square roots is multiply by the conjugate. So I'm going to multiply by the conjugate of this numerator. It's the square root of x plus delta x plus the square root of x. That's the conjugate of this two-term numerator here. Whatever I do in the numerator, I got to do the same thing in the denominator to be legal. to be legal about this, I got to do the same thing in the denominator. So in the numerator, it will clean up big time. In the numerator, you're foiling this out. It's this binomial times this binomial. You FOIL it out, but it's going to be like the difference of two squares. The middle terms will cancel. You'll get this times this, and that will be an x plus delta x. Like I said, the middle terms will cancel, so then you'll get minus this times this. So that's minus an x. All over, do not FOIL this out. You just have a delta x times parentheses the square root of x plus delta x plus a square root of x. Dude, this is pretty good. This is pretty good. I don't know if you can see it, but after what that conjugate did for me is that numerator's going to clean up. That x minus that x is gone. I can cancel those x's. And then I have a delta x over this multiplied delta x. I can cancel those. It leaves me with a 1. I am now left with this limit. As delta x goes to 0, I'm going to cancel those. It leaves me a 1 over this. Square root of x plus delta x plus the square root of x. I've done a lot of cool canceling. I've done a lot of cool stuff here. Cancel that. Left myself a couple ones. And there I am. But what I haven't done yet is done the limit. Now I'm going to do the limit, which means let delta x go to 0. Previous to this, if I would have let delta x go to 0, guess what? I would have had 0 over 0. But I finally fixed my problem. If I let delta x go to 0 now, I'll get an answer. This little delta x goes to 0, and I got the square root of x plus another square root of x. So I think the answer is 1 over 2 square roots of x. That's my new function created by doing this difference quotient and doing this limit of this difference quotient as delta x goes to 0. You do this to this function, and you create this new function called the derivative. All right, good luck. I got more to say in 2-3. I want to drop a ball off a building and talk about the change in height and the change in time. You know, the change in height could be my y values. The change in time could be my x values. You know, maybe I'm looking for a slope. When I put a height over a time, that's a velocity. That's a speed. So then maybe I'm getting a speed here or velocity here. Anyway, I'll do that in the next video. Thanks for listening. Try some homework.